Hello friends, in this video we will try to understand the loops available in Java. Let's have a look at what we have learned so far. We have seen different types of data types, so we have gone through so many examples on that, and followed by we also saw the operators, so different kinds of operators we have, and then in this class we will go through the scope and lifetime of the variables. We will try to understand the different modifications we have in the loops, and then we shall jump into the core classes concept. So coming to the loops, let's start with a simple for loop. Okay, so as we all know, since from the C and C++, a loop is used whenever we want to repeat some statements. Okay, so suppose now I want to display the value of n starting from 10 to 1. So now let's see how does this works. So I have tried to run this file. It is Shift F6. Yes, it is running. So it starts from for n equals to 10, from n greater than 0, and every time it's decrementing. And then for each and every value of n, I'm trying to print the message tick with the value of n. So for n equals to 10, tick 10 should be displayed, and then since it is ln here, this is print ln method, cursor should be placed in the next line, and then once again the loop iterates. So many basic things here. So this is the initialization, so this happens during the first time. Every time this condition is checked, n greater than 0, and after executing the loop body, before coming back to this for loop header, so this decrement operation is going to be performed. So here, so the value of n starts from 10, and every time the value of n is printed until n is greater than 0. So from the value of 10 to 1, we should be having the tick values. So here tick 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so what will happen if I change this to for n is greater than or equal to 0? So now for this we should have tick 0 also. So now let's check. So yes, we got tick 0 because n is greater than or equals to 0. So this is the common for loop what we have been learning since 2 years. Okay, so now a small modification here for this for loop. So now let's see what do we have here. In this example, I am having an array here, int nums equals to, as you can see, this is the first time I am trying to explain array concept in Java. I have kept it very simple, even though this is not the exact array definition we are going to use. So let's see further. So here the name of the class is for each, and we have this main method, and we have the string args. What is string args, my dear friends? It is command line arguments. Yes, in the first class we have learned how to pass values to the command line arguments, right? Okay, fine. So in the line number 13, I have initialization with declaration of this array by the name nums. So now, so based upon the number of values we are going to give, so the size shall be specified. So here we have the values starting from 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 10. So now automatically the size of this array is 10. Now I have another variable sum equals to 0. Before coming to this part, so now let's see what's the reason behind using this for each or for. So now see here, suppose I have this array size of 10 elements. Imagine I am doing a process where I'll be touching, or I'll be making use of every possible value within the array from its first index to its last index, that is from num of 0 to num of 9. Under this condition, where every location in the array is used, under those conditions we are going to use this variation of for loop, that is for int x to nums. So what does this mean? This means that this int x is the initial variable we have. Every time this for loop runs from the nums array, from the index location 0 to 9, every time nums of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, every time one number from this array shall be copied to x till its last index. For example, this is the first run. So during this run, nums of 0 shall be copied into x, and then in the next iteration nums of 1 shall be copied into x, followed by nums of 2, 3, 4, 5 up to nums of 8 and 9. So here, until we don't use break within the for loop, this loop will run 10 times, and every time starting from the 0th index to the last index, every value within the nums array, one by one it will be copied into x. That means right now, since assume that this is the first iteration of for loop, okay, so now let's take the nums of 0. What is nums of 0, my dear friends? Nums of 0 is 1. That 1 is copied into this x. System.out.println, value is 1. Value is 1, and this is assigned to sum. What is sum here? Sum is initialized to 0. Sum is equals to sum plus x. So initially the value of sum is 0. 0 plus 1 is once again stored into sum. So now the new value of sum shall be 1. So now this will be iterated back again, and this time the second value within the nums array, that is 2, will be copied into x. So value is 2. So this 2, which is in the variable x, will be added to sum. This is nothing but sum is equals to sum plus x. So this is nothing but sum is equals to sum plus x. So in the last iteration the value of sum was 1. Now that 1 will be added with the value 2, that is it becomes 3. Now the latest value of sum is 3, right? Okay, and once again it loops back to the for loop header. Now this time this is the third iteration. What is nums of 2? That is 3. So this 3 is copied into x, and then once again we'll be displaying the value of x, that is value is 3, and that 3 is added to the value sum. Sum initially had 1 plus 2, that is 3. That 3 is added to 3 again, so now we'll be having the value 6. Like this it will be iterating till the last value within the nums array. So here we need not keep track of the array variable, what we have been using as an I variable in C and C++, which was used to get to the index of the array. So for each style for loop and display, so this for each, so this syntax is named as for each, as the name itself is self-explanatory. For each of the value within the array, this needs to be done. So when we say for each, from the first value to the last value, every value within the array will be taken, and it goes and it will be used here within the for loop. So now let's look at this result. So this shall display 1 plus 2 plus 3 plus 3 up to 10. So what is this? 10 values, right? Okay, n into n plus 1 divided by 2 as per the mathematical induction. How many values? 10 values. 10 into 11. 10 into 11 is 110. 110 divided by 2 is 55. So now we should get this value as 55. So yes, we got the total summation as 55. So as we can see, value is 1 2 3 4 5 6 up to 10, and in the sum variable we used to do the summation of all the values within the array. So the answer, the summation was in the sum variable, so we printed the same thing with the message summation. Okay, so this is a simple example of for each loop which is rigorously used in Java. So in the next example we will see the other loops what we have inside the Java package. Okay, so now let's go to the next example. So now let's have a while. So now this is the example of a while. So take a look at that example. So here this is the second loop we are trying to discuss in Java. So hardly there is any difference in the way the loop works, but based upon the different conditions, different requirements, we go for loop or while loop. So when we know the exact number of iterations that this I need to loop this for, let's say 10 times, then we set the loop variables to execute it for 10 times. So that can happen in for loop. So during the while loop, I know only the condition until it's met, the loop has to execute. Under those conditions, we'll be using this while loop. So this is the same loop what we have seen in the for. So here I have got n equals to 10, but in the for loop, so we had this initialization n equals to 10 here. So this was the condition. Okay, so this is what I changed it. So this was the initial condition. N greater than 0 was the condition. So the same condition is written here. So we want the decrement to happen at the very end of the body, right? So that's why decrement was placed here. So the same loop written using the while loop looks like this. So initialized, test condition, and how we want to treat the loop variable. Okay, so this shall give the same answer. So let's see how it works. So here we have n is equals to 10. Is your 10 greater than 0? Yes, 10 is greater than 0. Print tick 10. Okay, and then decrement. So now the value of n decrements to from 10 to, now it becomes 9. Is your 9 greater than 0? Yes. Now it's going to display tick 9, and then the value of n is decremented. Once the value of n is decremented, we are going to have 8, and so on, my dear friends. So here, starting from value of n equals to 10 to n equals to 1, your n values are displayed using this while loop. So now let's check the output here. So starting from 10 to 1, the values are being displayed. So this is the simple demonstration of your while loop. And then let's go for a no body while loop. Okay, let's see what it does. So the name of this file is nobody while, and we have got the main method. Okay, int I equals to 100, j equals to 200. Now find midpoint between I and j. Okay, so now see here we have this test condition within while, but it does not have any body of its own. So this can be done very easily, because we know that whenever we are going to use a loop or a control statement, it's going to work on one statement at a time. If we are including two statements, then we need to include that within the braces. So now the loop of the body is a null body. So every time this is going to work, because see, there is no big deal here. This example exploits the increment and decrement operations what we have in Java. As we know, this is a prefix increment and this is a prefix decrement. So here the value of the I changes first, and then I gets the value, and that is used within the expression. So here also the value of j is decremented first, and then it is used in the expression. That means plus plus I. What is plus plus I? I, if you increment I becomes 101, and j becomes 199. Like this it's going to continue. When so this will I will keep on be incrementing from 100 to 101, 2, 3 up to 149, 150. Like this, every time from 101 to 150, this condition is going to be true, because j is decrementing from a larger value, that is 200. From 200, every time j becomes 199, 198, so on, up to 180, 170, 160, 155, and then sometimes it has to become 150, right? So now if we look at the output of this particular statement, then it says midpoint is 150. So a simple example here explains you need not even have a body of the while loop, but one thing what we all have to notice is it's having this semicolon. So let me take back you all to the previous example. Here we didn't have any semicolon included within the syntax of this while. But why do we have a semicolon here? It's having a semicolon here to show you where does exactly the while structure ends. So what will happen if I take this semicolon to the next line? So now let's see, hardly there can be any difference here. So this means that if we simply keep line number 17 as while plus plus I is less than I minus minus j, this will be associated with this line, because that's the immediate statement after that, right? So in order to tell that this statement is different and while is ending here, so we have this semicolon written here, my dear friends. So I hope you can work out on this, and as I have always been saying, you need to experiment, you need to practice with different values. So this is the loop. Okay, so now let's go for do while. So this is the third loop we have been learning in our life of computer science. And then, so now why do we need to go for a do while condition, my dear friends? So as I told you, for loop is used when I know the exact iterations within the loop. I'm going to use a while loop when I know the exact condition to be met, but I'm going to use a do while loop most probably at those times when I want to run the loop at least once. So we know, right? So we need to do this particular body of the loop once, and then this condition is checked. So, and we also know that this do while is called as a post test loop, because the test condition is written after the body of this particular loop. So irrespective of whatever might be the condition, the body of this loop shall be executed once, no matter what. So now I have used the same example, the one I have used with the for loop and the while loop, my dear friends. I have extracted all these programs from complete reference Herbert Skilt. So anyways, I'll be sharing this over at Modo, or else you can just do the copy paste thing from the complete reference. That's the prescribed textbook we have for this particular Java subject, right? Okay, so now here we have this do while class name, and then I have got the main method, and then followed by the, what is this? This is the initialization, right? So I need n to have a value before the loop starts. So do what? Do this body. See here, I'm not at all checking condition here before executing this body of the loop, right? So this condition is checked only after executing once, right? Okay, so system.out.println tick n. So what does this tick is the message I'm showing, and then followed by the value of n. What's the value of n? 10, because that's the value we are starting the value of n, right? Okay, and then I'm going to decrement n. So after displaying tick 10, now n's value gets decremented to 9, and then I'm going to check this condition: is your n greater than 0? True, very true. So let me keep track the value of n here. N becomes 9. So after executing this, go back to the do. So do it again. System.out.println tick. What's the value of n now? The value of n is 9. Decrement 9. 9 becomes 8. Okay. Is your 8 greater than 0? Very true. Once again, go back to the do. System.out.println tick what? Tick 8. Decrement n. So here 8 becomes 7. Like this, it keeps on decrementing till 6, 5, 4, 3, 2 and 1, and once again n becomes 0 also, right? That's what the stopping condition is. So now let's look at the output. So it says starting from the value tick 10 to tick 1, the values are decrementing from 10 to 1. So this is the general idea of your do while loop, and this is what we are going to see. These are the basic things we have been learning from C and C++, right? So the questions may not be targeting this exact behavior of this do and while loop. So questions shall target the usage of these loops in an application. Okay, so now we have got this last example. Okay, so this is once again the another usage of this for loop, for each, right? Okay. It is very easy. It has to, because we have learned all the core concepts, right? Nums. What is the nums array variable? Nums array variable contains some random jumbled digits here. 683756114. Okay, so now let's see what we are trying to do here. In this program, we are trying to search a number, whether we are going to see whether that number is present within this array or not. So the symbol searching algorithm is trying to be implemented here. So this is the number, this is the set of numbers, and within that set of numbers I'll try to check whether val, which is 15, is present or not. Of course it is not present, and that's what the answer should be. Okay, boolean found equals to false, so we need to initialize the value first, right? So initially the found variable, which is of boolean. So if you don't know the boolean, my dear friends, go back to my previous videos of data types, and then you can check the execution of the boolean. So here the value of found is false, the value of val is 15, and now I'm going to use this for each version of the for loop. Why? Because I'm trying to search. While searching, the number which I'm trying to search, 15, can be at any position, right? It's from the first position to the last position. So here, using this for loop, I'm trying to go to the every possible location and check whether the number is present or not. So this means that every location within the for loop, every location within the array nums is being processed or is being checked. When every location is being checked, we can go for each version of the for loop instead of keeping track all the loop variables, right? Okay. Now nums. So what's the value of nums? What's the value of first value within the nums? The first value is 6. That 6 is assigned to x. So the value of x is right now 6, and now I am trying to match it with val. Is your x equal to, this is the comparison operator, is your x equals to val? Is your 6 equals to 15? No, right? So when it is false condition, so this will be skipped. So we are going to come here, go back to the loop, and then the next value of nums. What's the next value of nums? 8. That 8 is assigned to x. Now once again I'm going to check, what is your 8 equals to 15? Nope. So this thing will be skipped. I'm going to come here and then loop back. So what's the next value of x? The next value of x is the next value in nums. What's the next value in nums? 3, right? So the value of x is 3. Is your 3 equals to 15? No. So this shall be skipped. Okay, like this, every possible value within the nums array shall be compared with the value of val, right? Okay. So now, as we can see, 15 is not present within this array. Now, value not found. So now let's see, where do we have that message here? Okay. So if found, so if this condition is true, we are going to make the found to be true, right? So if found is true, we are going to display value found. If it's not, we are going to display value not found. So now let's have a a fruitful value here. So now let's search for 1. So the 1 is present in the 7th position. So now let's check what's the value. Value is found because now I have changed the value to 1. 1 is really present here. Once the value 1 is found, that is 1 equals to 1, found becomes true. Once the value is found, no need to search again. So at any point of time, if you want to come out of the loop, so then we break the loop by the break statement, right? So when you break all the further iterations within the loop, and then you are going to come out. So this is where your for loop ends. When you come out, found is true. If found is true, the value being displayed is, the message being displayed is value found. So this is the simple example of loops we have in Java. Okay, and in the next part of this tutorial, we will try to understand the return statement, continue statement, and break statement. How do we do the branching? That's what we will try to understand here. So this is a simple example of the usage of continue statement in Java. So the name of the class is continue. Now why do we use continue? We use break to come out of the loop. We use continue to go to the initial position of the loop. Okay, that means once the continue statement is used or executed, all the further statements within the loop after continue shall be skipped, and the control shall be jumping back to the loop header, right? So we will try to understand it again, once again looking at this example. So once again, for theory's sake, why do we use a continue? Continue statement is used to skip all the statements after continue statement within the loop and jump back to the next iteration. Okay, so now we have got the continue class, we have got the main method. Okay, int I equals to 0, I is less than 10, I plus plus. Simple usage of for loop here. Okay, now I is equals to 0. Now I is less than 10. It is true. The value of I is 0. I is 0. 0 is less than 10. True. I am printing the value of I. What's the value of I? Value of I is 0. Right? Okay. Now what is 0 modulo 2, my dear friend? 0 modulo 2 is 0. Right? 0 modulo 2 is 0. Since 0 modulo 2 is 0, 0 equal to 0, the condition is true. You are going to print continue. So here I am not going to do this println statement, which is doing nothing, and then once this continue is executed, this statement is skipped here, and then once again we are going to go to the next iteration. So here I becomes 1, print the value of I. Okay, print the value of I. So we had printed 0, now we have the value 1 because we have a blank space here, right? Is your 1 modulo 2 equal to 0? What is 1 modulo 2? 1 modulo 2 is 1, and it is not equals to 0. So you are going to skip the continue, and now you are going to execute this one. What does this say? This says nothing because I don't have anything here. But what we can notice here, this print has got a println, and here we have got print. So whenever we are going to see a new line, that means this condition has failed. That's what we have to understand. So once I show you the output, you will understand how exactly it is. You can understand this one. So as you can see, this condition what we are checking here, I modulo 2, when this I modulo 2 will be equal to 0, I modulo 2 will be equal to 0 for every value which is multipliable by 2, right? So every other value is divisible by 2. So let's check here. Is your 0 modulo 2 is 0? Yes, that's why we have 0 in first line. 1 modulo 2 Is it equals to 0? No. So we didn't execute this continue. We came to this system.out.println. So I hope you can understand this now. Okay, so this is the basic example of continue. Continue skips the statements after the continue statement. Let's move on to the next example. Return. Okay, what is the main purpose of having return statement? Return statement always go to the caller. So who calls main method? My dear friends, Java virtual machine. That is once again, to be exact, Java runtime environment that invokes the main method within the Java program. Okay, and we use this return statement to terminate any method we are going to use in our program. So here, so I have not yet introduced methods here, so so now let's see the simple execution of this return statement. Here we have got the main method, boolean t equals to true. Initially I am initializing the value of t to be true. I am printing this message. What is this? Before the return. So as per the sequence of instructions, before the return is displayed. If t, what is t? T is true. If of condition, true condition. So whatever you write here, whether a variable or an expression, if it results in true condition, it is treated as true. If it results in false condition, then the control will go to the false block. Now the value of t is true here. So if it is true, then this return statement is to be executed. If this return statement is executed, the control once again jumps back to the Java virtual machine, that is, or the Java runtime environment. Once it jumps to there, we don't have any means of coming back to the program and executing this. That's why I have written this won't execute, right? So once again, the value of t is true. So before terminating this program, that is before going back to the Java runtime environment, I am printing the value or printing the message before the return, right? Okay. If condition. If t, what is if t? If of t is true. So if of t is true, hence it's going to return, and the only line of output what we will be saying is before the return. So once it returns to the Java runtime environment, so this cannot be executed. So I am using this can word, right? Cannot. So it cannot happen at all. It's impossible. Okay. Now let's execute. So before the return, right? So we are not seeing this particular message, that is, this won't execute. So now let's do some modification here. So now let me negate this one. So not t. So now let's see this execution. So it says before the return. Now I have negated the true, that is, if of condition becomes false. Once the condition is false, so we are going to skip this return statement. Once we skip this return statement, next statement has to be executed as per the sequence. So this won't execute, will be printed. So this is an example of how we are going to use these return statements. This example of continue will show us how to return to a particular label using these continue statements. So this may look a bit bigger and complicated because of for loop. Trust me, this is easy. Okay, fine. So many things to understand here. So now let's go through them one by one. We have got this class name is continue label. We have got the main method. We have got two for loops. This is outer for loop, this is inner for loop. Okay, the for loop, the first for outer for loop has been labeled as outer. Okay, and then whenever we are going to execute continue, my dear friend, it's going to take your control to the beginning of the current loop. That is, in this line number 17, I have this continue statement. It's going to skip all the statements after the continue, and it's going to take you to this for loop. But the variation what do we have here is, instead of going to the inner for loop using this label outer, we are taking this control to the outer for loop. That's the difference here. Okay, So now let's see the simple output here. So you may go through that execution on your own, but this is the fundamental thing to understand here. So int I equals to 0, 0 is less than 10 true, j equals to 0, j is less than 10 true. Is your if j is your 0 is greater than 0 false? If it is false, my dear friends, this entire thing is skipped. You're going to print 0 into 0. What is 0 into 0, my dear friends? 0 into 0 is 0. That's what printed here, right? Okay, so in this way we can get this kind of an output though. So here we can see the stepwise printing of 0, 1, 2, 4 and so on, right? Okay, so the concept to understand here is not what it prints, but how does the control gets transferred here. So once again, so here we have got two for loops. Whenever we are going to execute this continue statement, it's going to take your control to the inner for loop, that is the immediate for loop before within which the continue has been placed. But here with the use of the label outer, we are taking the control from inner for loop to the outer for loop. So that's the variation here, right? Okay, so now let's move on to the next package I have here. So now let me go through this variables, very, very important. So let's go through them. Let's start with the array, a very, very bigger one to start with, but it is easy. Okay, so let's try to understand this one by one. So what is an array? Array, my dear friends, we can define an array as continuous allocation of memory. So whenever we are going to declare variables are declared based upon the data type we are going to use, but they are not continuous. There is no guarantee that they are going to be continuous. So if I want continuous allocation of memory, I go for this array. Array can be one dimensional, two dimensional, multi-dimensional. So multi-dimensional is an illusion, right? So everything is single dimensional array, but using the one dimension, two dimension and three dimension, we get this illusion of having the matrix, box and so on. Okay, so how do I define an array? Is continuous allocation of memory whose location starts from the index value 0, right? Okay, so now let's see what do we have here. Here the line number 13 declares the month days as the variable array. So listen to me, my dear friends. Java has got a two-step way of allocating memory to its objects or to its arrays. So it's very, very easy. So once again, if you don't follow, we will be having the Zoom class to make up the doubts. So you can ask the doubts there. We have got the int month days. Okay, int month days. What is this int month days? Int month days is an array variable, but after the execution of line number 14, month days is a variable pointing nowhere because memory is not allocated at that point. Memory is allocated here using the keyword new. What is this new doing here? New allocates your memory dynamically based upon the size you are going to specify here. Okay, so now at this point, line number 14, month days, I know what a month days is. Month days is the array variable. Now when I say month days equals to new 12, it means that month days is a variable which points to the 12 continuous integer variable location. Okay, so this is the line which is going to create memories for you, and then month days is the variable which points to that particular memory. Month days is that variable which holds the location to the continuous allocation, right? So Line number 14 creates a variable. Line number 15 allocates memory. Okay, so now this is one more step complication, or else you can see, actually it's not complication, but whenever we are going to learn, when we're trying to learn Java for the first time, so this becomes one more step of thing to get stuffed in our head, right? Once again, what is this line number 14? Line number 14 creates a variable. So what it does, it creates a variable, but it does not allocate any memory to you. But here in this next line we can write it like this. So new int of 12 will give you the memory location. This can be condensed like this: int month underscore days, right, equals to new int of 12. So these two lines mean the same thing here. So actually this is the statement we are going to use to create an array, but this is the simpler example or explanation of the line number 17. So now once again go through here. New int of 12 is going to create 12 locations to store integers. I repeat, it's going to create 12 locations to store your integers, and since it is the continuous memory which can hold 10 integers, I'm going to name them by month days. I'm going to name them by month days. So this part is going to create the variable, and this part is going to create the memory, and this is equal to is going to assign this particular array name to this particular memory location. So this is what we are going to use as array. Okay, but there is simpler way. If you are going to create, as we have seen in the last for each examples, if we dynamically create the array with we are going to initialize the array while declaration, then we don't need this at all. Yeah, but as and when we get into the classes and we create objects to the classes, it will be more clear to all of you in understanding the statement. So explaining it once again, what this is going to do, this is going to create memory, allocate memory for you. Once the memory is allocated, this is the variable. So month days is the variable. So here it is mandatory to have this particular square brackets. Okay, so I'll just comment this one. So here month days of 0, 1, 2, 3, 4 up to 12. So here up to 11, sorry. So here as you know, so we have got this 12 months, and then I'm trying to store month days of 0, 1, 2, 3 up to 11. From January to December, I'm trying to store the number of days within that particular month. So now suppose now I want to see how many days does the April has. So where is the April? April is the 4th month, right? So month days of 3 should show me the number of days in April. So usage is same, my dear friends. So this is the array name and this is the index value, but the only new thing what we are going to understand here is the way of creating memory for this particular array. So I hope this gets clearer in the subsequent examples. Now this is an auto array, this is a student friendly array. So here we don't have that new and all those things. So here based upon the number of values we are going to initialize, automatically the size of the array is fixed. Size of the array is fixed dynamically based upon the numbers being initialized. Okay, so this is the same example. This execute this the output is the same, but in the last example we had declared values, we have declared memory, and then we had initialized the values, but here during the declaration itself we are trying to initialize. So now this should give me the same answer, my dear friends. Okay, so this is the simple example of an array. So now let's look at the average example, the same old traditional example what we have. Okay, so what is this? So here we are going to this fractional value. Okay, double nums. Okay, as you know, so since the data type section, I'm trying to explain you that every fraction value by default is a double value. If you want it to be float, you need to prefix that by f, right? Okay, so now let everything be the double here. So we will try to find the average of all these values within the nums array, and then we are going to final summation in result, and then we will divide it by the 5. Okay, doubles result equals to 0. Fine. Now this is inside the for loop, so now let me just indent it. For I equals to 0, I less than 5, I plus plus. So for I equals to 0 is this is the initialization, so this is the test condition. Is 0 less than 5 true? True, my dear friends. So the value of 0 is 5, 0 is I is 0, 0 is less than 5 true. What is nums of 0? Nums of 0 is nothing but 10.1. That's 10.1 is added to the result. 0 plus 10.1 is 10.1, that is stored in the result. And now this is the latest value of result is 10.1. Okay, now look back. This is the only statement within the for, as you know. So my difference, very basic things. I have only one statement, so that's why I have not used any braces. If we had multiple statements, we must have used this brace, that is. So I don't have this set of braces, right? Because I have only one statement, so I don't have any other statement to club with this one. Okay. Now the value of I is the value of I now gets incremented to 1, right? Okay, so now what is the latest value of result? Latest value of result I have kept track here. It is 10.1. so the now if I is 1, what is nums of 1? If I is 1, what is nums of 1? It is 11.2. Now 10.1 is added with 11.2, that is, what is the value here? This is 21.3, right? Okay, like this. When I gets incremented to 2, when I gets incremented to 2, the next value shall be dealt is 12.3. so this 12.3 is added to 21.3, and then the summation goes on. Now let's look at the value. The average is so 12 point so many values, so 15 to 16 values after the decimal digit, right? So these are the 3 examples what we have for one-dimensional array. So now let's have a simple example of a 2D array. So like this, my dear friends, based upon the programmer's freedom, you can have any dimensional array, right? Okay, so we have been understanding 2-dimensional array in the form of matrix, right? So let's continue with that particular concept, right? Okay, so let me just indent a bit. So now j is less than 5, j plus plus. Okay, now what's happening here? So now let's execute this program. Okay, it is simply displaying the values it's going to get, right? Okay, fine. So 2D, my dear friends, 2D, what is this 2D? 2D is the name of the array. What is this new int 4 or 4 5 is going to do here? So this is going to allocate memory, this is going to create the variable, and this is going to assign the variable to the memory. So that's how we are going to understand. Create memory, that is allocate memory here in the right hand side, create the variable in the left hand side, assign the variable to the memory. That's it. ijk equals to 0 for I equals to 0. So now this means what is 4 5? There are going to be 4 rows. So this is a 2-dimensional array which has got 4 rows and 5 columns, right? Okay, so always see the outer for loop is going to take care of your row number, and the inner for loop is going to take care of your column number, right? Okay, now what's the value of k? K is initialized to 0, right? So k is initialized to 0. So k is given to 2d of ij. When both I and j are 0, this is the first location within the 2d array. First location becomes 1, and then after doing that, I gets incremented to 1, that is initially k is 0. From 0, the k gets incremented to 1, and like this every row, every column is going to get an incremented value of k. Okay, and then here we are trying to print the 2D array. So every time, so this is the outer for loop, this is the inner for loop. So we have been learning this since 2 years, right? So I need not go through how the inner for loop and outer for loop works. See, the only thing we need to understand and verify is that by 1 gets incremented by 1, and then the output should be reflective of that concept. So as you can see, 0 1 2 3 4 5 6 7 8 9 up to 16 17 and 18 and 19. So this is the simple example of a 2D array. Okay, now let's go to the conversion.java. So now let's see what do we have here. So this example explains you the conversions, the type conversions we have, which some happen automatically, some are intentionally done by the user. So let's go through them. So as you can notice, the normal concept is that you imagine a bucket and you have a glass. When we say a bucket, my dear friends, bucket is a bigger container, and when we say glass, glass is a smaller container. We should never try to pour the water present in a bucket to a glass. So what will happen? We will lose the water, and in the program we will lose the precision, right? So imagine pouring a glass of water into a bucket. A glass of water, which is of small quantity, can be easily accommodated within a bucket, right? Bucket can easily store a glass of water. So that should be done. From a smaller data type to bigger data type should be converted. If you convert from a bigger data type to the smaller data type, then we lose data, or what we can say, we lose the precision. Okay, so now let's see how this is reflected here. Now byte B, the maximum value the B can have is negative. Smallest value is negative 128, bigger value is positive 127, right? Okay, system.out.println conversion of int to byte. So see, my dear friends, here the conversion is going from int to byte. So how we are going to do that? So now let's check here. In the right hand side I have I. What is I? The value of I is 257. Now I am trying to convert that to a byte. So what will happen if I remove this one? See, this is the magic of IDEs. So let's see, what does this balloon says? It says possible loss of precision. Possible loss of precision. See, my dear friends, even if I write this byte here, we know I is like a bucket, B is like a glass. There is no way I can pour the bucket full of water into a glass, but I'll show you what will happen. So the reverse values of from 127, after getting 127, once again the values from negative 127 shall be stored there in the byte. So just to explain you, I'll show you the output. Conversion of int to byte, I and B. Okay, so here we are not trying to print it, right? Okay, first let's see the conversion. So here we are trying to store an integer into a byte. Okay, system.out.println I and B. I is given by I value, B is given by B value. So now let's check the output here. So this is we'll try to understand this first line. So system.out.println I and B. See here, once I try to store I within B, B changes my I, but not I. I have not written anything here to change the value of I. I remains I no matter what. There is no modification inside the I. But here the value of I is displayed 257 because that's the initial value what I have initialized. But here the value of B gets 1. What's the value of B? B gets the value 1. So now let's see how it happens. So once I get this 257, so now let's okay, so what's the maximum value of maximum positive value of the byte can store? 127. you double the 127. What's the 127 into 2? 27 into 2 is 54, my dear friends. So 100 into 2 is 200. So that is 254. Now what I want you to understand here is, when you do this, the value what you're going to get within the B is little unpredictable. So that's why when you try to pour this I within the B, you can't say what can happen there. Similar thing with this B, is with this D. So see here, what is D? D is double. D is double. Now 323.142, which is the fractional value, I am trying to store within an integer. So what is the value of, what is the type of I? I is of type integer, right? Now I is of type integer, but this D is a double value. When you try to store this D, that is 323.142, I typecast it to int and then I store it into I. So here I lose the precision. I will lose this 0.142 and then I will get 323 as the answer. As you can see, 323 is the answer. Now let's look at the next one. Conversion of double to byte. Conversion of double to byte. What is this double doing? Double is the value 323.142. And that thing I'm trying to store within the byte. So this is just like pouring a tank full of water into a glass of water. So see what's happening here. So you wanted to pour, that is the value of D is 323. You want to store that into the byte. So here I get the value 67. I get the value 67, right? So we were not expecting that one. So the main thing what we need to understand while type conversion is, my dear friends, we should always try to typecast your smaller data type into bigger data type. If vice versa happens, then we will lose the precision as it is shown in this particular example. So what we have seen so far within this particular session, so we have a scene. Let's summarize. We have seen the different so what did we start with? We started with loops, and then we saw the return break statements, and then we saw the execution of arrays, right? In the next session, my dear friends, we will try to understand the lifetime, the scope of the variables, and then we will get inside the class concept. Keep coding, my dear friends. So if you have got any doubts, please comment in the comment section. If you have not yet subscribed to my videos, please do subscribe. Keep coding. Stay safe. Thank you.